Namaste. Okay. So, in this lecture, what we are going to do is we are going to solve the problems from HC Verma sir's book. So, HCV. The chapter name is Electric Field and Potential. So, we are going to solve the objectives. This is objective 1. Okay, that we are going to solve. So, let us read the question number 1. So, my sincere request to all the students is first, what you do, students, is you read the problem on your own first. Try to draw the diagram of that particular situation, try to write down the formula, try to put the values, try to analyze that particular formula qualitatively, which means if x increases, what happens, if x decreases, what happens, if r increases, what happens, what will happen if the sign changes, something like this. So it depends on the question that you are having. Okay, so all objective ones, I hope you all have tried this on your own, and then after reading the question, after solving the question, after giving it 2-3 attempts, then you are seeing this particular video, then only this will be useful. If you are continuously watching the video, then it's not going to be helpful for you. Okay, so let us start. So question number 1 is quite easy. Figure shows some of the electric field lines corresponding to an electric field. The figure suggests that, and so what I'm going to do is I'm going to put all the MCQs on the screen. Okay, so option A, so basically they are comparing the electric field. So the diagram is very simple. So here, if you can see, this is the situation, this is second line, and this is third line. Okay, so here the field line, the separation between field lines is same. So this is A, this is, let's say it is B, yes, and this is C. So electric field at A will be equal to electric field at C, which is greater than electric field at B, because the field lines, this closeness of field lines determines the strength of that particular field line. It is not the length of those field lines. Okay, so the electric field is traveling in this particular direction. So at A and C, the field lines, the field line separation is constant. So these electric field strengths will be equal, and at B, the electric field will be weaker because here field lines are separated. If somebody asks you to compare the potential, then we can easily see that the potential in the direction of electric field, the potential decreases. We all know this. So at potential at VC, here VB, and here let's say VA. So at VA, potential will be greatest, and at C, the potential will be least. We know this particular formula. You can think from this also, minus delta V by delta R. Okay, and we can think in many other ways. So there are so many MCQs that we are going to solve, so don't worry, we'll interpret those results also. Question number 2. So what is the answer of first question? The first question answer is C. Okay, then second question. When the separation between the two charges is increased, the electric potential energy may increase or may decrease, that remains constant, increases, decreases. Okay, so the separation between two charges is increased. We don't know the nature of charges, so it can be positive charge. Let's say this is Q1, at a separation we have Q2, and we know the potential energy of this system is equal to U is equal to K, Q1 Q2 divided by R. One important thing that we should know about this particular formula is, this is the potential energy of this particular system when you are assuming the potential energy at infinity to be equal to 0. Okay, so here if you can clearly see, as you are increasing R, when these both charges are positive, then this entire term will be positive. K is positive, R is positive. So if these charges are positive, this entire term will be positive, and if these charges are negative, this entire term will be positive. Therefore, as R increases, when the like charges are there, the potential energy of the system is going to decrease. Yes or no? But what will happen if the unlike charges are there? So which means if a proton is there and the electron is there, okay, then this U is less than 0, because positive negative or negative positive, this U will be here, negative number will be there, and in negative number, if you are going to increase R, when you are going to increase R, what is going to happen is this term will decrease, but it is decreasing in negative number, so it's actually increase. Okay, so what is the answer of this question? It may increase or decrease. So option number D. There is one more way of thinking about this particular question, which is as follows. When positive charges are there, or when both the charges are negative, when you leave them, when you release them, what is going to happen? They are going to run away from each other. When they are going to run away from each other, their kinetic energy is increasing, and the increase in kinetic energy is at the expense of decreasing potential energy. So potential energy of the system has to decrease. So in like charges, the potential energy of the system is decreasing when the charges are like, and when unlike charges are there, what is going to happen? because of this negative number, and its R increases, this in negative number it is decreasing, so potential energy of the system is actually increasing. Okay. Alright, this is question number 2. Then question number 3, let's try to solve question number 3. If a positive charge is shifted from a low potential region to a high potential region, then electric potential energy of the system, it increases. Definitely it increases. Why it increases? Let's try to understand. When the electric field is in this direction and a positive charge is there, yes, positive charge is shifted from a low potential region. So we know in the direction of electric field, the potential decreases. So this is clearly a higher potential point and this is a lower potential point. So from lower potential to higher potential, you are moving, let's say, a positive charge, which is, let's say, a proton. Okay. So what is going to happen if you release this proton from here? It is bound to travel in the direction of electric field because it is going to experience a force F is equal to Q into E. So you are moving this proton against its will, therefore you are increasing its potential energy. Are you getting my point? So you can also explain this by Q, the work done is equal to Q delta V, which is equal to Q V final minus V initial, and this is the burden of external agent that I am writing, not of the electric field. Okay. So when this final potential is greater and this initial potential is smaller, and you are moving from low potential to this work done will be greater than 0, and when the work done is greater than 0, the potential energy of the system, this work done is basically stored in the form of potential energy. Okay. All right. Now the next question, that is question number 4. Okay, so students, please understand, when I am explaining these questions, I may be using some concepts. So I am assuming that you have studied this chapter very carefully, your notes are updated, you have solved the questions given by your teacher, you have done the homework given by your teacher, and when you are coming here, at least you have attempted the one particular MCQ at least 2 to 3 times. Then only you are going to understand these things. Okay. All right. Then question number, let's say, question number 4. Let us try to solve question number 4. So what is the answer of question number 3? It increases. Okay. So this is option number A. It increases. Question number 4. Two equal positive charges are kept at A and B. The electric potential at the points between A and B, excluding these 2 points, is studied while moving from A to B. Then potential. It's a brilliant question. So ध्यान देना कि असं समजा की इथे समजा Q1 आहे चार्ज आणि हे दोन्ही चार्जेस आपल्याला पॉझिटिव्ह दिले. Both the charges are positive. 2 equal positive charges are kept at A and B. Let's say this point is A and this point is B. And you are moving from A to B, then what is going to happen to the potential? Okay. We know that the potential due to a point charge is KQ by R. Let us assume that you are at a distance, let's say X. Okay. And the separation between these 2 charges is, let's say, D. Then this remaining distance will be D minus X. Since both the charges are positive, there is no scope where the potential will be 0 at one particular location, because potential is a scalar quantity, and it is you are not going to add this vectorially. Okay, so don't think that in the midpoint the potential will be equal to 0. It will be 0 if this midpoint, it's not a line, this midpoint the potential will be equal to 0 if one is positive and other is negative. So, and the magnitudes is same. Nature is opposite and magnitude is same. Then exactly at the midpoint potential will be equal to 0. Now let us write down the potential is not energy, potential of this electric potential of this combination, that is KQ, and both the equal charges are there. So KQ by, we don't know, 1 by X plus 1 by D minus X. Okay, so you can clearly analyze this from this situation as X is decreasing, which means you are very close to this particular charge. As X is tending to 0, okay, as X is tending to 0, this will become 1 upon D. It's fine, no problem with this term. But when X is tending to 0, this term is going to blast and potential will run to infinity. Okay, and when the X will turn to D, which means from here this X is turning to D, which means very close to this B charge, what is going to happen is this X will turn to D, then this is fine. Okay, 1 upon D will come, but this thing D minus D will be equal, this term is going to get to infinity. Okay, so potential will again turn to infinity. So very close to this charge the potential is infinity, very close to this charge the potential is infinity, somewhere the potential in between it will fall. So if you draw the graph, that graph also we are going to study, don't worry. So the potential will first decrease and then increase. Okay, so the option number decrease then increase, the option number, question number 4, option number D. Okay. All right. So let us write down our answers. The first answer is C. Then the second one's answer is D. then third one's answer is A, okay, and fourth one answer is D. So students, whenever you are solving such a kind of MCQs, make sure that you put a time, you put a reminder that this is the time that you are giving to solving these questions, and at the end what you have to do is you have to check your score, okay, then only we are going to improve by regular practice and giving ourselves a feedback of what exactly we are doing, what kind of mistakes that we are doing. We have to keep track of each and everything. Then question number 5. The electric field at the origin is along positive x-axis. A small circle is drawn with the center at the origin, cutting the axis at ABCD, having coordinates A0, 0, A. We are getting a feel that it's a circle, respectively. Out of these points, the periphery, out of the points on the periphery, the potential is minimum. Again, a very simple question, students. Let's say this is y-axis, this is x-axis, and the electric field at the origin is towards x-axis. And we have drawn a circle where the points are A, 0, then this is, let's say, point A, then the B point is 0, A, this is minus A, 0, and this is 0, minus A. This is B, this is C, and this point is D. Okay. So we know that since the electric field, if it is everywhere the electric field is like this, these 2 points will become at same potential because the equipotential surface is perpendicular to the field line. Okay. And in the direction of electric field, the potential decreases, so here the potential value has to be minimum, so it is the point A. Okay, so it is question number 5, option number A. In the last, we will check all the answers. Then question number 6. One of my suggestion to you is, when I am explaining this particular thing, try to interpret this thing by using different formulas, minus delta V by delta R, Gordon is equal to Q delta V. Okay, try to think about these formulas, try to get the result, because when we are going to solve the problems, at that time we are going to do the calculation and we are going to go in slightly more depth of the things that we are discussing. But these are some standard results that we should know, and we should know these results with the feel of the concept, with the formula, with how this formula we are interpreting, how this formula is giving that particular result. How are we able to think in terms of energies? Are we able to think in terms of this formula? Are we able to think in terms of graph and so on? Okay. Question number 6 is the body is charged. Again, a very simple question, students. These are, let's say, 2 bodies are there, or any shape bodies are there, and these bodies, when they are rubbed at this particular point, let's say this become positively charged, this become negatively charged. It is becoming negatively charged because of excess of electrons. So clearly the electrons have jumped from this body to this body. So this body has gained mass, and this body, due to loss of electron, has lost the mass. In a macroscopic scale, this mass is not going to make any difference. That's why the questions are really good. Here they have said that remains precisely constant. So this is not true. It is not going to remain precisely constant. So it may increase or decrease. The question number 6, the answer is D. 6, 5, 4, 3, 2, and 1. Okay. Then let's say question number 7. Let us solve question number 7. Elevated dipole is placed in a uniform electric field. The net force is 0. We all know. The 7th question number, option A, is the right answer. This is the electric field that we are having. Okay. There is a standard proof also in CBSE curriculum. So here, let's say minus charge is there, here plus charge is there. The electric dipole moment will be from negative to positive. So on this charge, the force will be in this direction. On this charge, the force will be in opposite direction. And as long as this electric field magnitude is electric field is constant, if this electric field is constant, then what is going to happen is this force is always going to get cancelled. So F net is always equal to 0. But tau is not equal to 0. There will be some torque acting on it. Okay. You can think about stable equilibrium, unstable equilibrium, but that's it for now. Question number 7, option A. Question number 8. Let us solve question number 8. Consider the situation. Again, a very simple question. The work done in taking a point charge from P to A, then is WA, then P to B is WB, then P to C is WC, and we have to compare. Very simple question, students. So here charge is there, and this particular point, let's say here A is there, here B is there, here C is there, and here let's say point P is there. Am I right? Yes. And you are moving from P to A, then B, and then C, and different burdens are given, and we have to compare them. We know that this is a charge Q, and this whole here the field lines will be like this. Away from charge, it's a positive charge. Therefore, the equipotential surface will be a sphere. So on this sphere, you go anywhere, the burden will always remain same because here the potential is constant. So what you are going to write down? Burden by external agent. that is work done by external agent is equal to Q delta V, which is equal to QV final, and this VF minus VP, and this VF can be VA, VF can be VB, VF can be VC, and all these potentials are same. That's why this work done will be same, and the option of question number 8 will be C. Last question. A point charge Q is rotated along a circle in an electric field generated by another point charge Q. The work done by electric field on rotating charge in one complete revolution is again 0. And there is a beautiful question at the end, that is in option D. What they are saying is 0 if the charge Q is at the center and non-zero otherwise. So let's say this plus Q charge is here, and you draw a circle here like this. Okay, and you rotate a small charge Q in this particular circle, then the force will be in this direction and the displacement will be in this direction. If the charge is, let's say, here, then the displacement will be in this direction and force will be in this direction. So always theta is equal to 90 degree. So work done is equal to Fs cos theta, which is theta is 90, so work done will be equal to 0. But even if this charge is not at the center, the field lines anyways will be like this, and you are rotating this particular charge here. The field lines here will be like this. So this electric field is a conservative force. It is independent of path, what kind of path you are taking. And in a closed loop, just like in gravitational field, in a closed loop, this work done has to be equal to 0. So the answer of question number 9 is A. Okay. All right. So that's it. Objective 1. We'll check now all the answers. So 1 is C, okay. Then second is D, third is A, fourth is D, fifth is A, sixth is D, then seventh is A, eighth is C, and ninth is A. Oh, okay, all are correct. So students, one more suggestion that I wanted to give is, even if your all MCQs are correct, sometimes what happens is you give a wrong logic to get the answer of a question. So at that time we have to be very, very careful. That's why whenever you are solving the MCQs, you are now right now at the beginning of the 12th standard, then you have to solve the MCQ by multiple approaches. At least use some 2 to 3 minutes of time on each and every MCQ. When you will think in that way, when you will think in terms of graph, when you will think in terms of formula, when you will think in terms of signs, when you will think in terms of energies, and different approaches when you will use, and you will get the same result, then what is going to happen is this will really strengthen your concepts. Okay, in the upcoming lectures we'll dive deep into it and we'll solve some even good problems. Okay, thank you so much. Vande Mataram.